Hey, welcome to iFlip for Math Mathcast, Lesson 9-6, Common Factors and Greatest Common Factors, otherwise known as GCF. I'm Mrs. Gooding, and our quote tonight is by Paula Deen. I am living proof that the American dream still exists. It is still alive and well. There's only one trick. You have to be willing to roll up your sleeves and work very, very hard. I don't think you'll have to work super hard to learn greatest common factor today, but math can be hard work and you can be successful at it, but you're going to have to roll up your sleeves and work very, very hard. Our learning goal today is to use the strategy make a cake to determine the greatest common factor of two numbers. Our individual lesson learning goals are review the divisibility rules to help determine the factors of a number. If you've forgotten those divisibility rules, guess what? Number one, they're listed on the website under resources, and number two, they're under video lesson Mathcast 4-7. So you can always go back and rewatch lesson 4-7 to review your divisibility rules. And remember, that's the great thing about the Mathcasts is anytime you've forgotten something, you can go back and find the lesson that talks about it, rewatch it, and that's a great review for you. We're also going to use a T-chart. We did that to find factors earlier in the year, to find the common factors of two numbers. That was in that lesson 4-7 as well. And we're going to use the make a cake strategy when we only need to find the greatest common factor, when we don't need to find all of the common factors, just the greatest common factor, which is what we really do with fractions. There's going to be a lot of pictures of cake in this lesson, so I hope I don't make you too hungry. Just think it's worse for me since I low carb, I don't eat cake, so well, it wasn't that tempting for me. Here's our vocabulary, and there's Paula Deen with a football for you guys and girls that like football. Factors. Factors are numbers that are multiplied together to get a product. Example, the factors of 8 are 1, 2, 4, and 8, and they're listed out that way. We would have put them in a T-chart if we were doing that before. 1 times 8 is 8, and 2 times 4 is 8. Common factors, that's if you have two different numbers that you're comparing and you list out all of their factors in two different T-charts. Any numbers that they both have in common are common factors, or CF. Like 2 is a common factor of 8 and 16 because 2 times 4 is 8 and 2 times 8 is 16. Greatest common factors, if you look at those list of factors in the T-chart and you look at the ones that they both have in common, the biggest one or the greatest one is the greatest common factor. So for example, in a T-chart, 8 would be the greatest common factor of 8 and 16. Here's our example. We're going to do two things. We're going to review how to find those common factors just so you've got it. We're going to find the common factors of 32 and 24, and we're going to find the greatest common factor of 12 and 15. So we're finding the common factors of 32 and 24, so I went ahead and wrote them both on our screen over T-charts. Remember, 1 is a factor of every number, so I'm going to write 1 here, and 1 times 32 is 32. Remember, we've kind of got a little multiplication symbol right in the middle, and this is our product here. We know that 2 is a factor of 32 because 2 is an even number. 32 ends in an even number. So 2, and we might have to do some division to figure that out. I happen to know that 2 times 16 is 32. Remember, to find out if 3 is a factor of 32, we can add up 3 plus 2, which is 5. 5 would be our digital root for 32, and if it's a factor of 3, it's going to have a digital root of 3, 6, or 9. So 3 is not a factor of 32. 4, because it's an even number, we should try it. Let's see. 4 times 8 is 32. 5 is not a factor because it doesn't end in 0 or 5. 6, let's see, 3 plus 2 is 5, doesn't have a digital root of 6 or 9, 3, 6, or 9, so 7, remember we have to do that the old-fashioned way. 7 times, well, there isn't 7 times any number equals 32, so. And then we're back to 8. We're back to 8, and we've already got our 8 here, so we don't have to start over. And we're listing out our factors. Remember, we list them out in a horseshoe. Hopefully that is a quick reminder of how to do that. So if we're doing 24 in the same way, 1 times 24, we know it's even numbers, so 2 times 12. 2 plus 4 is 6, so if it has a digital root of 6, 3 is a factor, and 3 times 8 is 24. 4 times 6 is 24. 5 is not a factor. It doesn't end in 0 or 5. And 6 is already listed right here. So if we were listing out our factors, we would list them from 1 to 32 and 1 to 24. Looking for our common factors, 1 is a factor for both of these numbers. 2 is a factor for both of these numbers. 4 is a factor for both of those numbers. There it is. And 8 is a factor of both of those numbers. Now, if we're looking for the greatest common factor, it's the greatest common factor. It's 8. 8 would be the greatest common factor. But I'm going to teach you an easier way of finding that greatest common factor, and it's through making a cake. So we're going to start over and make a cake. GCF, I'm going to write that at the top so I know what I'm doing with my cake, because you don't want to be looking for the wrong answer with your cake. We're going to do 12 and 15. So I'm going to put those two numbers in the bottom of my cake. Oh, scary lines. Put a comma between them. And what number will divide evenly into 12 and 15? Well, 2 won't, because 15 isn't an even number. So let's try 3. 3 goes into 12 and 3 goes into 15. Yep, that'll work. 3 goes into 12 4 times. Put a comma. 3 goes into 15 5 times. Now we're going to make another layer. What number will divide evenly into both 4 and 5? Just 1. 1 goes into 4 4 times. 1 goes into 5 5 times. So remember, for the GCF, we're only looking at the layers. You may want to write that in your note. The GCF is the layers. 3 times 1, I'm multiplying the bottom layer by the second layer. 3 times 1 is 3. So the GCF of 12 and 15 equals 3. That's supposed to be an equal sign. Equals 3. That was a lot faster than listing out the factors in a T-chart, coming up with common factors, and then coming up with the greatest common factor. So let's go practice some of those. Okay, here's some more cakes for you, and here's our practice problem number 1. Find the GCF of 9 and 12. Make sure that you show all of your work in your flip journal. Remember, that's required to complete your homework. So pause it, do your work, and push play when you're ready. Did you write 3? Let's see how we did that. So we're finding the GCF of 9 and 12. So we're going to make our cake. There's our bottom layer, 9, comma, 12. What number will divide evenly into both 9 and 12? 3. 3 goes into 9 3 times. 3 goes into 12 4 times. And now we're making another layer. What number will divide evenly into both 3 and 4? And that would be 1. 1 goes into 3 times, and 1 goes into 4 times. So we know we're done because these two sets of numbers have repeated. So remember, to find the GCF, we multiply the layers. 3 times 1 is 3. So the GCF of 9 and 12 equals 3. We can even just write that like that. Let's try another one. Number 2, find the GCF, the greatest common factor, of 7 and 28. Pause and push play when you're ready. Did you write 7? Let's see how we did that one. So we're going to make a cake to find the greatest common factor of 7 and 28, and we'll write them in the bottom layer. What number divides evenly into both 7 and 28? There's only 2. 1, which we don't want to use yet, and 7. So we'll put a 7 here. 7 goes into 7 1 time. 7 goes into 28 4 times. There's our second layer. What divides evenly into 1 and 4? 1, that's right. 1 goes into 1 once, 1 goes into 4 times. We're done because we're repeating those two numbers right there. So remember, in our layers, to find the GCF, we're going to multiply 7 times 1. So the greatest common factor for 7 and 28 is 7. 7 times 1 is 7. Number 3, find the greatest common factor of 18 and 32. Pause and push play when you're ready. Did you write 2? That seems mighty small for the numbers 18 and 32. We better check that, see how we did it. So we're going to put 18 and 32 in the bottom layer of our cake. And I'm going to divide them both by the easiest number I know to divide them both by, which is 2, because they're both even numbers. So 2 goes into 18 9 times, and 2 goes into 32 16 times. New layer. What goes into both 9 and 16? 1. 1 is the only one. 1 goes into 9 9 times, and 1 goes into 16 16 times. So we're only looking at the layers going up the side. 1 times 2 is 2. We were right. Here is our practice word problem for the night. I'm going to read this aloud to you. Number 4. At Stephanie's Bakery, Stephanie bakes 1 batch of 20 chocolate chip cookies and 1 batch of 10 oatmeal cookies each day. Stephanie sells all her cookies the same day in gift baskets. So she's not putting all of those into one gift basket. She's putting an equal amount of both types of cookies in a gift basket. Because her customers expect consistency, consistency means they want the same type of content in each basket. Stephanie wants to make sure each gift basket is identical. That means exactly the same. What is the greatest number of identical gift baskets that Stephanie can sell each day? I want you to pause it and I want you to think about this. Kind of play around with it on your paper, see if you can figure out what to do. And if you can't figure it out, I want you to push play for a hint, but then stop it right after you push play. Okay, in case you couldn't get it, here's the hint. What is the greatest common factor of 10 and 20? You may have drawn a picture to figure this out, and if you did, that's okay. But if you found the greatest common factor, that's going to help you too. So go ahead and see now if you can work it out. Pause it and push play when you're ready for the answer. Did you write 10 gift baskets? Let's see how we did that one. So hopefully you made a cake and put 10 and 20 in the lowest layer. What goes into 10 and 20? Well, 2 does. 2 goes into 10 5 times. 2 goes into 20 10 times. You might have picked a different number here, and that's okay because it'll all work out the same. What goes into both 5 and 10? I'm going to use 5. 5 goes into 5 once. 5 goes into 10 twice. What goes into both 1 and 2? 1. 1 goes into 1 once. 1 goes into 2 twice. I'm done because I'm repeating that number there. So I'm actually going to circle these numbers for GCF. 2 times 5 times 1 equals 10. It's time to challenge yourself. At a track and field competition, there are 18 sprinters and 21 long-distance runners and 90 fans. Christopher has to assign all of the athletes to teams. He wants to make sure all of the teams have the same number of sprinters and the same number of long-distance runners. What is the greatest number of teams Christopher can form? So think about that. Show your work in your journal, and we'll come back and explain it tomorrow in class. Finishing up, go ahead and make sure that you understand what we did in this lesson. Write down your level in your flip journal. 1, if you're still struggling. 2, if you pretty much got it, but you still have a few questions. And 3, if you've got it. Greatest common factors. You've completed lesson 9-6, common factors and greatest common factors. I can't wait to see you tomorrow.